Grouping with others is a common response to the challenges of life, and one that appears to have evolved multiple times.
Hello everyone, this is So Animalia.
And today we talk about mixed species shoals. While the great majority of research into the ecology and evolution of grouping behavior has focused on single species groups, mixed species animal groups are widespread in nature. A mixed species group is a group of any size composed of two or more species of independently moving animals that remain close and interact with one another. Forming and maintaining such groups is advantageous for at least some of the participating species. Mixed species groups may benefit from a reduction in the intensity of food resource competition if different species within the groups exploit different foods or search for food in different niches. In general, shoaling has those advantages all animal groups have, like increased foraging efficiency. For example, both goldfish and common minnows locate food patches faster when in larger shoals. They may also benefit individuals' foraging success via group vigilance, which reduces the need for individual vigilance and therefore increases time allotted to foraging, i.e. the many eyes hypothesis. Members of mixed species groups might also gain anti-predator benefits beyond those available in single species groups. Just like flocks and herds on land, more eyes are better, even if different eyes. Mixed species groups can exist at a range of temporal scales, from stable associations that persist in the longer term to groups that form on a seasonal basis, to much more transient groups, where species associate for short periods of time, often hours or minutes before separating. They seldom contain equal number of species, rather one or two dominate, with others present as small minorities. Minority members of mixed species groups might suffer costs associated with being odd. Yes, but they might often still do better by grouping than if they remained alone. Mixed species shoal formation could theoretically result from a solitary individual choosing to join the only available shoal, comprised of heterospecifics, over starting its own shoal, i.e. remaining solitary until joined by others. Stingrays preferred to rest alongside whiperays, and when in mixed species groups, whiperays responded earlier than stingrays to an approaching mock predator, suggesting that the whiperays benefit disproportionately more from the association. There is evidence to show that fish recognize and respond to heterospecific alarm cues, interspecific eavesdropping, and that information transfer between species does occur with respect to direction of movement in mixed species shoals. But how these fish decide to follow a different species? Is it just random? Well, in chops, it was seen olfactory cues lead to recognition of joining of same species shoals, and visuals to interspecific shoals, preferring same species with both senses. Of course, these systems may vary depending on fish and its preferred sense. The question now is, if you could choose between same species individuals and different species, you would think animals always choose their own, right? Right? Well, nature is all about adaptability. Different species often eat different things. Diet partitioning between species may minimize within shoal food competition, but in contrast, an equal competitive ability between species may be costly for inferior competitors. So in some cases, it may be beneficial to choose a different species over yours. In addition to benefits associated with diet partitioning, foraging associations are known to be an important driver of the formation of mixed species shoals. Wrasse associating with goatfish made more bites on sand than solitary wrasse, suggesting that wrasse gain access to an otherwise inaccessible food source by forming shoals with goatfish. Foraging associations may also provide benefits via the circumvention of territorial food competitors. This phenomenon has been described multiple times for mixed species shoals containing surgeonfish as a core species on coral reefs. Satellite species including midnight parrotfish, tangs, and multiple other fish form mixed species shoals with surgeonfish to gain access to algal mats, which are aggressively defended by territorial damselfish. Shoaling may benefit predators in similar ways. Individuals hunting in larger shoals may be more likely to encounter prey due to collective vigilance and coverage of a larger volume of space. Not shoaling but bats actively aggregated whilst hunting, suggesting benefits associated with collective vigilance and eavesdropping. And you can see my video on nuclear foraging association to see a similar case in fish. One important group of fish that quite a number of studies have reported being the nuclear species is the goatfish, a group that I personally witnessed many times in mixed species groups. In fact, the stirring up of sediments by goatfish leads to the uplifting of formerly hidden organic material into the water column. This activity attracts other species that follow goatfish and feed on the newly available particles. For example, the wrasses I said before. Goatfish themselves may profit, because foraging in larger groups may reduce the predation risk. Heterogeneous shoaling may also facilitate access to defended resources by swamping the territories of egg-carrying reef dwellers, such as damselfish. Similarly to what happens with the surgeonfish I talked previously. The diversity of species that forage with goatfish illustrate the extent to which social foraging events occur. Goatfish are bentivorous and are associated primarily with fish that are like them, but other fish that eat plankton or fish have been observed as well. Fish of various trophic groups have been observed to be the focus of most mixed species foraging groups in many studies. And if many other cases found anti-predator benefits in mixed species groups, a contrary result was found for which individuals of some species abandoned groups when threatened. This paradox may occur because the protective merits of mixed groups differ among species and individuals. For example, if the predator in question is particularly interested in preying on you. In another study, distinctive coloration and low numbers make juvenile stoplight parrotfish odd and vulnerable in groups. Their intraspecific agonism may increase risk in a group by attracting the attention of a predator and/or limiting the number of conspecific members. This species uses the reef rather than groups for protection. A small home range and close association with the substrate presumably allow familiarity with safe hiding places. In contrast to stoplight parrotfish, juvenile striped parrotfish often numerically dominate mixed groups. Their tendency to roam over large areas may limit familiarity with available shelter sites, and as in pelagic fishes, lead to schooling as a form of cover seeking. Thus, the various species differ in their tactics for avoiding predators, while behavioral flexibility allows individuals to tailor these responses as needed. This shoaling thing, even between conspecific, is a behavior that favors diversity. Subtle variations in the phenotype, familiarity, experience, state or personality of conspecific group members can benefit individuals in some cases. An important example is seen in shoals where dominance hierarchies or leader-follower dynamics operate. In such cases, shoal function is dependent upon within-shoal variation in, for example, body size or swimming speed. Faster, free-spined sticklebacks occupied the peripheries of shoals and were more likely to be the leaders in the collective movement of shoals containing both fast and slow individuals. Such organization may drive efficient collective movement and therefore benefit individuals due to predator confusion and collective vigilance. Mixed species shoals may benefit in similar ways to this heterogeneity. Also, shoals containing more experienced members may benefit naive individuals by social learning about food location and predation threats in novel situations. Lastly, it is important to notice how these mixed groups may possess subgroups within and how this subgrouping may be beneficial. Comparing within and between show differences in cohesion and alignment for mixed and single species shoals containing the Indo-Pacific surgeon major damselfish Abiodeftos vigensis. I love his name, Abiodeftos. Sounds like a made-up gibberish. Anyway, as expected by this comparison, this fish that I don't want to repeat the name, mixed species shoals were less aligned than single species shoals. Of course, however, within mixed species shoals, conspecific were more cohesive and aligned than were heterospecifics, suggesting that coordinated single species subgroups formed within larger mixed species shoals. The formation of subgroups may mitigate costs associated with differences between species, therefore enhancing benefits of mixed species shoaling. As you can see, nature finds many ways to benefit diversity. So, did you know of this behavior? I know there was a lot of different information, but basically the idea is that you can't always group with members of the same species, or may even benefit from joining different animals, and that's why such strange associations occur. If you happen to see one, follow it for a bit. Find out which species is more numerous, what they eat, when they separate. You may notice something new. Hope you enjoyed. Subscribe, porco Dio.